Hey guys, it's Miss Schroeder. I am doing the every other odd problems from numbers 59 to 91 that should coincide with your homework tonight. That was every other even numbers 60 through 92. Please excuse my pathetic handwriting as I am just getting used to using a stylus. Thanks. Good job doing your homework. I'm proud of all of you. When you're dividing two radicals like this, as long as they have the same index, which both of these do, there's an assumed 2 here and an assumed 2 here. You can use the quotient rule, which says that if you have a radical in the numerator and a radical in the denominator, as long as they have the same index, you can put them under one radical. So I'm going to make one radical, and I'm going to put 14 over 7 underneath it. Now, the reason we would do this is because we know that 14 divided by 7 is 2. And so then we can simplify this to the square root of 2. And that's our answer. Now, when we're talking about a problem like this is actually 5 times the fourth root of 48 over the fourth root of 3. So we can use our quotient rule for the fourth roots of 48 over 3. So we can make it 5 times the fourth root of 48 over 3. Okay? And then if we take 48 and divide by 3, you get 16. Okay? So then we have 5 times the fourth root of 16. And we all know by now that the fourth root of 16 is 2. So this is technically 5 times 2, and we know that 5 times 2 is 10. Okay, so this one is very similar to the one we just did. The only difference is now we've got some variables underneath the cube roots. So this is technically 8 times the cube root of 54m to the 7th over the cube root of 2m. So what we can do is we can take 8 times, since both of our indexes are 3, then we can do 8 times the cube root and do one big cube root, 54m to the 7th over 2m. Now what this does for us is it allows us to reduce the 54 over 2 and the m to the 7th, because this m will cancel with one of these m's, making this m to the 6th, and 54 over 2 can be reduced to 27. So what that leaves us with is 8 times the cube root of 27m to the 6th. Slide this up a little bit. Now you can also look at this as 8 times the cube root of 27 times the cube root of m to the 6th. If cleaning it up like that makes it a little bit easier for you to see, you can definitely do that. And we know that the cube root of 27 is 3. And if we want to figure out the cube root of m to the 6th, we just take our exponent and divide it by our index. So it becomes 6 divided by 3. So this becomes m to the 6th divided by 3. And we know that 6 divided by 3 is just 2. So this becomes 8 times 3 times m squared. So if we want to clean this up a little bit, we know 8 times 3 is 24. And m squared we're just going to leave alone. So our answer is 24m squared. Okay, we can immediately see that right here we have two indexes that are the same. They're both 4. So I can go ahead and write this whole big problem under one root using the quotient rule. So it's 96 a to the 10th b cubed over 3a squared b cubed. Okay, so let's see if anything cancels or if we can reduce anything. The b cubed, we know the b cubes go away, right? They cancel each other out. A squared gets canceled out in the denominator, and it makes a to the 10th, a to the 8th. And 96 divided by 3 is 32. So I'm left with the fourth root of 32 a to the 8th. Okay? Now, 32 is not a perfect fourth root. There's nothing times itself, times itself, times itself that's going to give me 32. So I need to simplify the fourth root of 32. So I'm going to break this up into the fourth root of 32 times the fourth root of a to the 8th. Okay? Now, the fourth root of 32, I'm going to take this right here and I'm going to break it into my factor tree. What times what gives me 32? Well, I'm going to go 8 and 4. 8 times 4 is 32. And then what times what gives me 8? I'm going to go 4 and 2. What times what gives me 4? I'm going to go 2 and 2. Now, I usually cross them off once I've broken them up. That way I know at the end exactly what I'm left with. And what times what gives me 4? 2 times 2. Now, you know in the rules of simplifying that in order to take a number out to the front, you have to have however many the index is. So I need 4 of the same number in order to be able to pull something out to the front. So I've got 1 2 here, 2 2s, 3 2s, 4 2s. So that gives me a 2 out front that I can have. And then anything I have left, I usually put in boxes, just in case I have more than one thing and then I know what to multiply together. So it's going to be 2 times the fourth root of 2. And we know that when we are taking the fourth root of a to the 8th, using the rules we used in section 7.2, we can take this 4 from the index and make it our denominator. So this is actually a to the 8 over 4. And we know 8 over 4 is just 2, so this is actually a squared. Now, a squared is outside of the radical. So it's actually 2 times a squared. So we'll say 2a squared times the fourth root of 2. Okay, and that is our answer. All right, now we're going to move into the part of the section that is the distance formula and the midpoint formula. Now we know that the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That is a formula that you will need to have memorized for the test. Excuse me. All right, this is usually what I do. I write my points. And then I label them. So I do x1, y1, x2, y2. And this keeps me from making any mistakes when I'm plugging into my formula. So when I plug into my formula now, I need x2. So I'm going to look down here. Here's x2. I know 1. X2 is 1. Minus x1 is negative 3. So be real careful there. It's minus a negative. Squared. Plus y2 is negative 3. Minus y1 is just 2. Squared. Okay. So now I'm going to clean this up a little bit. 1 minus negative 3, you're going to add a line, change the sign, right? So this becomes 1 plus 3, so you actually have 4 squared plus negative 3 minus 2 is negative 5 squared. 4 squared we know is 16 plus negative 5 squared is positive 25. Because remember, a negative times a negative is a positive. Okay. 16 plus 25 is 41. So the distance is the square root of 41. However, when you're talking about distance, if someone asked you how far you ran, would you tell them that you ran the square root of 41? Or would you tell them that you ran an actual distance? So go ahead and plug the square root of 41 into your calculator. and you're going to get approximately, that's the symbol for approximately, 6.403. And because they didn't give us a unit, we're just going to say units. You should always write something. So if they don't give you a distance, go ahead and write units. Okay, so our distance between those 2 points was approximately 6.403 units. Okay, so again here we're going to use our distance formula, which we just said is the square root of x2 minus x1 squared plus y2 minus y1 squared. So again, I'm going to label my points. So I have 0, negative square root of 2, and the square root of 3, 0. So I'm going to do x1, y1. They're both 1 because it's my first point, and x2, y2. They're both 2 because it's my second point. So when I go to plug in, I'm going to say the distance equals the square root. The first thing I want is x2, right? And where is x2? x2 is right here. So the first thing I want is the square root of 3. Minus x1, right? So here's x1 is 0. Squared plus, next I want y2. My y2 is right here, that's 0. Minus, then I want y1. My y1 is right here, that's negative square root of 2 squared. Okay, so again, be real careful because right here I have minus a negative. So you have to be real careful there. So let's clean this up a little bit. The distance equals the square root of 3 minus 0 is just this, anything minus 0 is just itself. So that's the square root of 3 squared plus 0 minus negative square root of 2. We're going to add a line, change the sign. And so it's going to be the square root of 2 squared. Okay. Now we know that the square root of 3 squared, the square root and the squared are going to cancel each other, leaving you the absolute value of 3 plus this square root and this squared will cancel, leaving you the absolute value of 2. The absolute value of 3 is just 3. The absolute value of 2 is 2. So our distance is the square root of 5. But again, we're not going to say that our distance is the square root of 5 because no one has any idea how much that is. So we're going to say our distance is approximately 2.236 units. Because again, they didn't tell us. But we always have to write some form of units. So if they don't give it to us, we're just going to write units. All right, now we're moving on from the distance formula to the midpoint formula. And the midpoint formula says m equals x1 plus x2 over 2, comma y1 plus y2 over 2. So whenever you're done with the midpoint formula, you're going to end up with an ordered pair. You're going to end up with an x, y. This will be your x value, and this will be your y value. Okay, so you'll always end up with a coordinate pair. So again, just like I did with the distance formula, I'm going to label my points. So I've got 6, negative 8, and 2, 4. So this is x1, y1. Remember, they're both 1 because it's my first point. And then x2, y2, they're both 2s because it's my second point. So now when I go to plug in, the first thing I want is x1, right? So first I have m is equal to, now I want x1. This is x1. So I have 6 plus x2, which is here, just 2, 2 over 2. And then I want y1, which is right here, y1, negative 8 plus y2, which is right here, and is 4 over 2. Okay, now that I've plugged in all my numbers, let's clean it up a little bit. 6 plus 2 is 8 over 2. And then negative 8 plus 4 is positive 4. I'm sorry, negative 4. Negative 8 plus 4 is negative 4 over 2. Okay, so I'm going to go ahead and reduce or simplify, whatever you want to call it. We know that 8 divided by 2 is 4. And we know that negative 4 divided by 2 is negative 2. So our midpoint is 4, comma, negative 2. Okay, so we're going to use the midpoint formula again here, which we just said is x1 plus x2 over 2. Comma, y1 plus y2 over 2. Okay, so I'm going to go ahead and write my points, and then I'm going to label them. x1, y1, both 1 because it's the first point. x2, y2, both 2's because it's the second point. When I go to plug into my formula, the first thing I want is x1. x1 is right here. So I'm going to say 7 plus, then I want x2. x2 is right here. So plus negative 1 over 2. Then I want y1, which is right here. So I'm going to say 3 plus y2, right, which is negative 3. All divided by 2. Okay, so then I have m is equal to 7 plus negative 1 is the same as 7 minus 1, which is 6 divided by 2. 3 plus negative 3 is the same as 3 minus 3, so that's 0 over 2. And then the last thing I need to do is go ahead and reduce or simplify. So you have 6 divided by 2, you get 3. And 0 divided by 2, 0 divided by anything is 0. So in this case, our midpoint is 3, comma, 0. All right, last but not least, we're going to go ahead and do the midpoint formula one last time. So I have the midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. The first thing I'm going to do again is go ahead and write my 2 points down here and label them so I don't get confused when I'm plugging in. x1, y1, x2, y2. Okay, so when I go to plug in, the first thing they're asking me for is x1 plus x2. So I'm going to say the square root of 2 plus the square root of 2. Okay? The square root of 2 plus the square root of 2 over 2, comma. Then they want y1 plus y2. So y1 is 3 square roots of 5, and y2 is negative 2 square roots of 5. So y1 is 3 square roots of 5 plus y2 is negative 2 square roots of 5 all over 2. Okay, talking about our x coordinate here, the square root of 2 plus the square root of 2, they are like terms, and when you're adding radicals, they have to be like terms. Your radicand has to be the same, and your index has to be the same. So in this case, our index is 2. Remember, there's an imaginary 2 here and here. And our radicand is 2 in both. So therefore, we can go ahead and add them together. So the square root of 2 plus the square root of 2 is 2. square roots of 2. And don't forget your over 2 that you have right here. Okay? And then over here we have 3 square roots of 5 plus negative 2 square roots of 5. My index is 2 here and 2 here. And my radicand is 5 here and 5 here. So I can add them together. So you just add the numbers out front. So in this case, you're basically saying I have 3 square roots of 5 and I have negative 2 square roots of 5. So when you add them together, you say 3 plus negative 2 is just 1 square root of 5 over 2. Now when we go to clean this up a little bit, since both of these 2's are on the outside, I can cancel them. So this 2 and this 2 cancel, leaving me just the square root of 2. And you guys know we don't write a 1 like this. We can just leave it as the square root of 5. So this is going to become the square root of 5 over 2. So our midpoint in this case is the square root of 2, comma, square root of 5 over 2. Now you have completed your homework. Congratulations. Have a great rest of the night, and I'll see you guys tomorrow.